Hi, this is Doug with Database by Doug. Continuing our indexes on index cards, we're going to cover clustered index reads. If you haven't watched the SQL Server caching video, that's the first in the series, you might want to go back and check that out. Clustered indexes are very important fundamental data structures for relational databases and are pretty foundational to how non-relational work also. So, the setup here is the SQL engine on the right, cache in the middle, disk on the left. Interactions between the SQL engine and cache are called logical IOs, and they're in the order of nanoseconds because RAM is very fast. Interactions between cache and disk are physical IOs, and they're in the order of milliseconds, which is roughly about 1,000 times slower than logical IOs. Requests for pages come in from the SQL engine. If they're in cache, then they get returned immediately, and it's a very fast operation. If it's not in cache, then we're going to make the request from disk. Disk will place it in cache, and that copy will remain in cache even after the page is returned. So I've used index cards here to represent data pages, and each data page in SQL Server is 8K, and as you can see, this is the actual data. It's an ID, that's the primary key. It's kept in order there. There's page 1, page 2. Notice that every entry on page 2 is greater than those on page 1, and the entries on page 2 are in order by ID. Everything on page 2 is less than everything on page 3. So all the data across all the pages is kept in order by the ID, which is the primary key of this table. We would say that this table is clustered on the ID. It's kept in order by the ID. There are lots of fields and lots of columns in this table: first name, middle initial, last name, date of birth, and weight. But it's only ordered in one way. So when I take all these records, I choose which column I'd like to order it by, and that's what we call the clustered index. So the clustering key is the ID. Now, also part of that clustered index is this page, what we would call a non-leaf page, and the first column represents a person's ID, and is the ID of the person on the first page. So this table represents all of the IDs, the first smallest ID on each of the data pages. So as we go through and look at page 2, you'll see that that second entry is the top entry on page 2. So again, this index page is each entry, the top or lowest entry of each data page, and the page number. So it's used to basically navigate across the data pages. Together, collectively, the orange sheet or the orange card page, the index page, and the data pages, collectively we'd call that a clustered index or a table. So here's some examples. We're going to select the first name from the person table where the ID is equal to 28423. We look in the cache, nothing's in cache. So we go make a request, and the request is for the index page. And instead of we don't take the page out of disk, we actually make a copy of it, put it into cache. Now the SQL engine can read it. So we look at that page, and what we will find is that if page 6 is too high, page 5 is lower than what we're looking for. So if that record's anywhere, it's on page 5. So I'm going to look through, find page 5, make a copy of it, place that copy into cache, and if that ID is anywhere, it's on page 5. So now we'll look through page 5 to see what we find. There it is. And the answer to our question, to our query, is Julie. So this is what we call a clustered index seek. We were pretty smart about finding these records. So we'll go through another example. Here we're looking for 36022, and if it's anywhere, it's on page 6. And what do you know? We already had page 6 in memory. Again, this is a clustered index seek, but in this case, it was actually 2 logical IOs for that one. So now we're going to look for things where the birth date is a certain value. And of course, this table is not sorted by the birth date. So how do I do it? Well, ultimately, so here we go, we're going to look through it, and we did find there's Julian up at the top that has the same birth date, but you know, there might be others. So we're going to look through all of those, and that was one logical IO to look at that page. And now we're going to take 2 more of the data pages because we got to look at every value, and we're going to scroll down through that. Don't find it here, don't find it there. And the database engine is going to have to continue doing this, moving pages into the cache, looking at them, putting 2 new pages into cache, looking at them, in order to verify or find every value. So there's just Julian and no more. This is what we would call a table scan or a clustered index scan, and it had 1 logical read and 6 physical reads. So that was a fairly expensive operation. Now we'll go back and do this again, 24085, look for that, and notice that we happen to have cache full, and we need that clustered index page. So we're going to have a physical IO to get that. We're going to look at it, 24085, and if it's anywhere, it's going to be on page 3. And we're going to look at that. Is that page 3? Nope, not page 3. So we're going to have to remove that from cache and go get a copy of page 3 and put it into cache, and then look for the 24085. So a lot of the expense is very dependent on what pages happen to already be in cache. So that was 2 physical IOs in order to do that clustered index seek. And then we're going to do this again. In this situation, we actually are able to find the same ID on the same page. So these last 2 operations are both clustered index seeks. One of them took 2 physical IOs, very expensive, and the other one took 2 logical IOs, very inexpensive. So all seeks are not created equal. Now there's a couple of other things that a index page can be really helpful for. So what if I just want to see if there's a record exists? I can look at just the clustered index page, and for this value of 3000, the smallest entry in the whole table is 4333. All I had to do was look at this index page and realize that this 3000 ID just doesn't exist at all. And I can do that as a clustered index seek with 1 logical IO. So let's do another one. How about ID 38850? If I look at that index page, I can find the value as the top value of page 7. And again, I can stop. If all I really want to know is whether it exists or not, I can do that with 1 logical IO. Thanks for watching. This is Database by Doug. I hope you enjoyed the video. If you did, please like, subscribe, and I'll be interested in your comments. Thanks.